Good morning. Good morning to all.
Good morning, sir.
Good
Good
morning, sir.
morning, sir.
Good morning, sir.
Good morning,
Good
sir.
morning, sir.
Sir,
Okay. I have shared the DIP, the PPT of
Good
digital
morning,
image
sir.
processing. Good morning.
Good morning, sir.
Okay.
Thank you, sir. Very helpful PPT.
Okay.
Thank you very much, sir.
Have
Please
you gone through
continue.
it? Any issues?
No, sir. Very nice PPT.
I found your group contains at least your group has 272 plus 272 members. But you have joined only 30. Do you have any idea what about others? Or all are the members, all are the student of the MCS, or there are other members? Have you any idea?
I
Sir,
The
I
think
group I
think they are from different semesters and MCA distance program. I think they are all in that group. And we are here fourth semester MCA all, yani ki MCA online.
Yes, sir. There are some other teachers in there as well.
okay. Acha.
So here we are all MCS 230 students, and they are in that group. They are students from all other courses, so that's why they are not here.
Okay. Are they belongs to other semester, third to second, or all are fourth semester?
different semesters, sir.
Different semester, sir. And sir, there are offline students also.
Mm-hmm. Okay. Uh, okay. So let us start. Uh, in the last class, we have discussed what is the introduction to DIP. What is an image is? Why need we process an image digitally? And there are some type of image. They are classified based upon different components, based upon their attributes, based upon their other components. And the last topic was the transformation of 2D signals. As you know, an image is a 2D signal. It consists of 2D signals. The image consists of some pixels, which is the smallest unit of an image, digital image. And the pixel has two values. It associated with two values. It is location and its intensity value. It is color value. So that is why it is known as the 2D signals. And sometimes we need to transform that signals to one form to another form. And the transformation uh, uh, is of two types. One is your forward transformation and inverse transformation. Uh, mm, you see, this is a handwritten example. Uh, is it visible clearly?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Here, so you see this is an maintain image. Image is not here, but the intensity value of an image is given, which is F. Prove that M and the transform works, you maintain image. You see here, I have taken F as the original image, and I have taken it a small example. So I have taken a matrix of order 2, which 2, 2, 2, 1, or it contains two rows, 2, 2, and 2, 1. And uh, and I'm going to apply the forward transformation as well as the backward transformation. You see here, the forward transformation is given by, we know that G is equal to A into F into A, where 1 by A equal to 1 by root N, and this is where A equal to is given 1 by root 2, 1, 1, 1 minus 1. And as N is 2 here, so 1 by root 2. So I am applying here a G is, that is 1 by root 2 A into F into again A. So now 1 by root 2 into 1 by 2 become 1 by 2. Now you see the first two matrices multiplied, 1, 1, 1 minus 1 into 2, 2, 2, 1, and gives you 1 by 2, 4, 3, 0, 1. So then the resultant matrix, which is 4, 3, 0, 1, will multiply the third matrix, 1, 1, 1 minus 1, and you will find multiply these two matrix, multiplication of two matrix. You please recall that is the matrix multiplication rules. You will go to the row wise and the column of second matrix, and please recall the number of rows of first, the number of columns in the first, it must be equal to the number of rows in the second. At that case, two matrices are comfortable for multiplication. So we will get the final G is, that is the transformation matrix is 7, 1, 1 minus 1. That means you see the initially was F was 2, 2, 2, 1. These are the intensity value. Now it is converted after transformation is 1 by 2, 7, 1, 1 minus 1. So this is the new value or new intensity value of F. So this is the transformation from F to G. And now I want to back my original form, and I want to get my original matrix or original image. So the inverse transformation is exactly, that is A inverse G into A inverse. That is inverse transformation. You see here A inverse. I have not calculated the A inverse detail. I am writing A inverse 1 by 2, 1, 1, 1 minus 1. That is, you know that the A inverse equal to, you have to find the adjoint of all the element, and then divided by the determinant value of A. So 1 by root 2 is the constant term, and 1, 1, 1 minus 1 is the A inverse. So I'm multiplying F equal to A inverse into G into again A inverse. So you see the multiplication. I have multiplied both the matrix first, and then there are you see 1 by root 2 into 1 by 2, again 1 by root 2. So it is 1 by 4, and your multiplication given 8062. And when multiplied by 1 by 4 in each element, we will get F22, F2221, which are the original matrix. So I have taken the intensity value of an image in a matrix form, and then apply the forward transformation to get a new value. And sometimes the new value is more required than the old value. We'll discuss about that. And if you want to get your original value, you have to apply the inverse transformation. You have to apply the corresponding inverse function of the forward transformation. Here, for example, I have multiplied a matrix A in the forward information, and similarly, we have multiplied the A inverse in the to get the original matrix. So your forward transformation function and inverse transformation must be opposite to each other. That is, here I multiplied A in the first case, I am multiplying A inverse in the second case. So in this way, this is a small example, that is forward transformation and inverse transformation. Then the next the image enhancement. So as the name suggests, enhancement. So it a technique. It is a technique improve the quality of an image as perceived by human observer or machine visual system. So as the name suggests, in image enhancement, it enhances the quality of an image. There are some techniques used for this purpose. Enhanced technique improve the perception of information in an image for human viewing and provide better input for other automated image processing techniques. So this technique is used to improve the quality so that we will get more information from an object. The main objective is to modify the attribute of an image to make it more suitable for a given text. So the main objective is to modify the attribute. There are different attribute uh, uh, of an object, of an image. So we have to modify that attribute. Suppose pixel is an attribute, so we have to take the pixel value. We have to modify that pixel value. There are some filters is used for that purposes. Image enhancement techniques are application specific and produce a better image. They are broadly classified into two categories: spatial domain method and frequency domain method. So there are some methods, there are some techniques used for these purposes, and these are basically divided into two parts: partial domain method and frequency domain method. In partial domain method, pixel values are manipulated directly to get an enhanced image. The pixel value you can manipulate directly. There are some methods we'll discuss on the later slides. So the pixel value you have to directly edited that, manipulated that. Whereas in frequency domain method, firstly, Fourier transform of image is taken to convert image into frequency domain. So first we have to convert to the frequency domain. Then the Fourier we have some technique of Fourier transform. Fourier transform that is in later sided. What is Fourier transform? We will decide that. We will discuss that. Then the Fourier transform is manipulated and the modified spectrum is transformed back to the spatial domain. So let us discuss the spatial domain enhancement techniques. Where you can directly manipulate the intensity value or the pixel value. So the pixel value or gray value of an image are directly manipulated. Such operation simply take the gray value of each pixel neighboring pixel, map it to a new value and move on to the next pixel. That is, if the some pixel value is spurious, that is, you have some idea that this pixel value is spurious, this pixel value has some error, you may manipulate it by comparing this pixel value with its neighbor value. We'll discuss about that. There are some filters used for that purposes. And such operations simply take the gray value or that pixel value, that intensity value of each pixel, and map to a new value and move on to the next pixel, pixel by pixel. So let f of xy be an input image. An image processing operation in the spatial domain may be expressed as the mathematical function t of fxy applied to the image to produce a new image GUV you can write, or GXY, whatever it may be. So GVB is written here, TXY you write. So GXY equal to T of fxy. So fxy is the input image. We have to apply the function, mathematical function T, and after applying the function, we will get another value which is GXY, which is a new value of f of xy. And the GXY value is enhanced value, that is GXY is the improved value of f of xy. So for that purposes, we have to apply a mathematical function in the spatial domain. So let us discuss what are those mathematical functions. The first technique is constant stretching. We have already discussed the constant in the previous class. The constant, it is a property, it is a characteristics of an image. Construct C between two labels x1 and x2 are defined as the absolute values of the difference between x1 and x2. So C of x1 x2 equal to x1 minus x2. You know that good constant is an image is important to distinguish the detail, else they will merge in background. So good constants of an image improves the quality. Low constant image occur due to the bad or non-uniform illumination condition or due to non-linear image of acquisition devices. So the main idea to reduce the low level gray values and to increase the mid-range gray values. That means here we have to improve the low level gray values. We know that the gray values for a 8-bit image, that is, it varies from 0 to 255. It has 256 distinct values. So here is the main idea to reduce the low level gray value and to increase the mid-range gray value, so that an artificial constant is created between the two set of gray values. This constant between gray values is thus stretched from both sides. So let us see how this technique is useful. Mathematically, the transformation is defined as the S equal to alpha R if it between 0 to A, where so there are some mathematical function you given, beta is equal to R minus A into plus SA, and gamma is equal to R minus BSB, where alpha, beta, gamma are slopes of different region in figure. We have a figure in the next slides. The slope determine the amount of stretching. If the slope is greater than 1, the corresponding gray label are stretched because the original gray label are mapped into larger range of gray values. A slope smaller than 1 means the constant is diminished. That is gray label values or slope may be greater than 1 or may be equal to 1 or may be less than 1. So there are three options for a slope. If it is a positive, so that is the constant is increased. If the slope is smaller than 1, suppose 0.5, that is the constant is diminished. If the slope of 1 indicate no 1, if the slope is 1, that is UV multiplied 1, so there is no constant alternation. So the parameter of A and B are user defined, and figure 6 shown the example of image enhancement using constant stretching. You see here, here is the image. We will go for that, but before that, you see there are some criteria of clipping and thresholding. That is, if alpha gamma equal to 0, this is called clipping. This operation stretches the constant to its maximum in a limited range, 0 original gray label values. That is, you have to take the maximum value. Maximum, that is, if the value is A to B, you have to take the maximum values. All the gray label outside the window are either mapped to 0 or maximum value. That is, you have to do range, you have to take in the range A to B. And if any gray label value lies beyond the range A to B, it is either mapped to 0 or maximum values. Thus, clipping allows us to focus all the available constant onto the required range of gray label values. This is especially when using a viewing medical image such as a CT image. So when viewing a CT scan image, the clipping is used. It is also helps the viewing under the overexposed image. Similarly, the another is thresholding. Alpha gamma equal to 0 and AB equal to T. So that reamping they call thresholding. And this operation, you see binarize only two values present the image. That is, the image will contain only two values, either 0 or 1. So a suitable threshold value T is selected, it's chosen. All the gray level you see here, the criteria is, the condition is, all the gray labels smaller than T are mapped to 0. Suppose the T is 120. If suppose T is 120, the threshold value is 120. If the gray label value is 10, so it is mapped to 0 because it is less than 120. Suppose the gray label value is 200. As I taken T is equal to 120, so 200 is greater than 120. Then the 200 is mapped to the maximum 255. That means you will not get any color besides than 0 and 1. That is black and white. So the gray label greater than 1, greater than T are mapped to maximum value. So I am repeating again, all the gray labels smaller than T are mapped to 0, whereas the other gray label greater than 1 or greater than T, not 1, T, are mapped to maximum value. So this is very useful operation in image processing application. Binarization is generally done before segmentation, origin extraction. So you see figure 7 shows, this figure shows an example of thresholding where T is equal to 110. You see the input image is grayscale image, as output image is binary. You see the 7A, 7E, A is the input image, the original image, and 7B is the output image after thresholding. You will get, after thresholding, you will view only two values, only two color, black and white. But in original image, it contains some gray color. It contains white color, black color, and also some gray colors also. The combination of black and white. So after thresholding, you will get only two colors. And the effect of thresholding, you see, there is an example. Thresholding of an image segment fxy with T is equal to 128. That means you see the first matrix or first box, which contains the gray label value of intensity value of the original image. The original image 0, 10, 50, 100, 595, 150, and last row is 175, 210, 255, and 100. So thresholdings, you see here, T is taken as 128. That means any gray label value less than 128 is mapped to 0. And the gray label value more than T 120 is mapped to 255. So you see the output of the right side matrix, that is 0 0 0 0, that is it is less than 128, that is it is mapped to 0, and the others are greater than 0, 200, 150, 255 is greater than 128, greater than the threshold value, and that is why it is mapped to 255. So all the gray label values between 0 and 255 are eliminated. That is, you will get only either black color or white color. No other color are there after thresholding. So this is a one type of transformation. So thresholding one type of transformation from one form to another form, and you will get the difference between the thresholding or before thresholding an image or after thresholding an image in the picture. 7A and 7B. 7 is the before thresholding and 7B is the after thresholding. Then after thresholding, no other color you find, you look either black or white, or either 0 or 255. But the original image contains 0, contains 255, contains any other value between 0 and 255. This is a graphically shown how the constant stretching, clipping, and thresholding works. So you see the last alpha beta equal to T. So you will get one horizontal line and one vertical line, but they are equal. And if you compare the two images below, it is a low constant image and it is an enhanced image after constant stretching. You will find the difference. That is how the quality is enhanced after transformation. Then digital negatives. So a digital negative means that is you will get a darker, if there is a darker pixel in your image, it will convert it to brighter, the corresponding brighter. And the corresponding brighter, if there is a brighter pixel, it is converted to corresponding darker. That is 0 will be converted to 1. That is 0 will be converted to 255. 1 will be converted to 254. So this is a negative trend. You may view the negative image of any image of your camera, of your mobile phone camera or any other camera. There is an option to get your negative of your any image. Have you seen in your this option is available in your camera? Have you ever seen?
No, sir.
Yes. No.
No, sir, we have not.
No, that is an option. You may view it. Okay. And previously, nowadays reel is not there, but in previously there are some reels, and you find the reels are negatives. That is, if the picture is the black color, that is your reels contain the white color, corresponding white color. So this is called digital negatives. That is the digital negative on image with 0 to L minus 1. L is your 256. So I have written L minus 1, 0 to 255. L is the maximum value. So we'll as we start from 0, it is 0 to 255, and it is obtained by subtracting that value from 255. That is the negative value of 10 is 255 minus 10, 245. Okay, that is, you know that 10 is darker, but its negative value is 255 minus 10, 245. 25 is not darker, 25 is brighter, whiter.
So as a part of this, the lighted thing is becoming dark and the dark thing is becoming lighted, is it?
Obviously, you see the image.
What is R here, sir? What is R? S is equal to L minus 1 minus R. What is R?
R is the original value of the pixel. Suppose you have a pixel value 10, so R is equal 10 here. Okay, so S is
Value in the original image, no sir? Value in the original image.
R is the original value and S is
And when we
the
have
new
to
value.
find the digital negative, we will do this formula.
Yes, 255 minus L minus 1 minus R. L minus 1 minus R. It is written there, L minus 1 minus R. And R is the pixel value of original image, and S is the pixel value of new image after negative. After digital negation, the S is the new value.
पहले कैमरा रोल्स निगेटिव आते थे सर, वैसा ही ना?
हाँ पहले आता रील्स जो है, हाँ एग्जैक्टली ट्रू. Okay, so the highest gray level of map to lowest value and vice versa. For a ADPT image, the transformation is S equal to 255 minus R, and it is written that is R is 20. R is a dark pixel, you know. R is closer to 20, is closer to 0, so it is a dark pixel. And after negation, that is 255 minus 20, the value of S is 235. So 235 is not darker. 255 is not a dark pixel, it is a bright pixel. So if R is similarly, if R is 125, which is a darker pixel, and X is equal to 255 minus 125, 130 is the value of S. So note that the middle gray level value has not changed. That is, suppose the gray level value of 127. Suppose R is 127. So what is the value of S? 255 minus 127. So there is not significant change. The gray value of 127 and 128 is almost same. That is, you find no difference or very little difference. The gray level is 128 and 127. So the here the middle level gray value has not changed significantly. That is, here is R has 125, you see. R is 125 and S is 130. So there is no significant change. That is 130 is brighter than 125. I know that, but it's a very small record. That is, you will not get any significant change. The same thing is written here. The middle gray level value has not changed much, whereas the dark gray level value has become bright. So the dark level value become bright, and the bright value become dark. But the middle gray level value do not change significantly. This transformation is generally used to enhance the white details embedded in the dark region of an image where the black is dominant. So if black is dominant here, so you can convert it to the corresponding white color. That is, if your image contains suppose 90% black color, 80% black color, so you can apply this digital negative techniques to get a brighter picture. It is useful in displaying medical image even though the visual content of both images are same, it is much easier to analyze image in negative form. So you see the original image and the digital image in A and B. In A, where the original pixel is there, some bright color are there, but the corresponding bright color is converted to dark color in figure B. So this can be done in transformation. So find the image negative transformation of an image. F is given by. So you compare it is not the threshold. The thresholding is different, and the digital negative is also different. Threshold value means that is if a particular value is less than threshold, it is mapped to 0. And if a particular grade level is greater than the threshold value, it is mapped to 255. But here the value is subtracted from the maximum value 255. You see 0 is converted to 255. 0 is the first row, first column in fxy. But you see the solution gxy, 0 is mapped to 255. And you see the next is 10. In first row, second column, 10. So 10 is mapped to 245, 255 minus 10. And corresponding the last you see, last column, 100. Last row, last column. 1 minute. So this is the digital negative. Intensity level slicing. A variant of thresholding is intensity level slicing or double thresholding. It is also known as the double thresholding. Please recall, in thresholding, you have to take a threshold value, and if the particular gray level value is less than that threshold value, it map to 0, otherwise it map to 1. But in this operation, it is used to highlight a range of intensity values of the interest of image. Suppose you want to view the intensity level of an image or gray level value of an image between 150 to 200. 150 to 200, that is the range. Suppose 150 to 200. In that case, in this slicing, intensity level slicing and double thresholding is used. The idea is, the criteria is in this operation, all the gray levels in a window A to B, that is there is a range, A to B is given, are set to maximum gray level values, 255. The other gray level value, which is beyond this range, are set to 0. So it is one type of thresholding. It is one variant of thresholding. In their thresholding, and these are same. Only difference is in thresholding there is a fixed value. As our example, please recall T was 128. The gray level value less than 28, 128 is mapped to 0, greater than is mapped to 255. But here in place of 128, we have to take a range. Suppose 100 to 150, or 100 to 100 to 100 to 200, or 150 to 250. So we have to take a range. If any gray level value lies on that range, in between that range, so it is mapped to 255. Or any gray level value is less than that range, is mapped to 0. It is also a binarizing method, like your thresholding. Intensity level sizing is also a binarization operation, and that resulting image has only two gray level values, 0 and M. So it is a special type of thresholding. Mostly, this technique is used to remove unwanted element, which is the term used is clutter for that. Clutter is a term used in image processing, which used was to remove the unwanted elements from an image so that the useful information become prominent. Applications are enhancing certain features which are based upon the gray level values, such as mass of water in a satellite image. Suppose you want to view the water in satellite, you have a satellite image, but you are interested in only viewing the mass of water in that picture. Cancer cell in a monogram image, suppose there is a patient's image in monogram image, you want to view a doctor is interested to view on the cancer cells, particular cancer cells, and the cancer cells have the particular gray level values. You apply this intensity level slicing method, binizing method, and that cell will be only visible, and the other are mapped to the other color 0, and only the cancer cells are mapped to the white color. Example. Okay. So, are you getting intensity level slicing? It is a one type of special case of your thresholding. Thresholding a particular value is given, but here a range is given. Otherwise, it is same as thresholding, and you will get more clear if you take the applications. That is cancer cell in a monogram image, mass of water in a satellite image.
Sir, can you explain with an example?
An example, you see. Example given. Suppose there is a report of a monogram image of an patient. Suppose you can tell your ultrasound. Suppose a ultrasound report of a patient, and now it is viewed by a doctor. And doctor is only interested to view the cancer cell of that report. And you know that is your monogram image contains various type of gray level values. There are different type of image, and it contains various type of that is varies between 0 to 255. Suppose the cancer cells has the gray level values between 200 to 250. 200 to 250. That means I am only interested to view, that is the doctor is only interested to view the gray level value that is lies between 200 to 250. Okay, so use this method. That is the gray level value which lies between 200 to 250 is converted to white color. Is converted to white color. And the other gray level value.
Sir, that range is converted to 255.
Yes, obviously. That is white color.
And rest are
converted to black color.
Black color. So I can see only that tumor or cancer cells in white color. And
exactly 100%. Yes, true.
Okay.
Okay. Similarly, mass in water satellite image. There is satellite image. You have to only interested to see the mass of water only.
Sir, what is 0 and M? 0 means to 0. M means here
maximum value. 0 means your white color. M means the maximum value.
0 means white. 0 means black color.
Black color. Yes. That is after this, you will get an image which is either 0 color or M color.
M means
255 here. Maximum value. 255.
Yes. White color. Okay.
Yes. That is you can tell 01 or 0255. M is the maximum value. Because as we discussing about M bit, so the maximum value is take 255.
255 is what? White?
White. 255 is white, 0 is black. So you will get like thresholding. You see the thresholding in previous example, you will get the output image which is only 0 and white color. The other color are absent. The other color is not there. All the other color are eliminated. Similarly, it is also a special case of thresholding. But in thresholding, we have to take only one value, 128. Any value less than 128 is converted to 0 or black color. Any value greater than 128 is converted to black color. Sorry, white color, 255. But here we have to take a range. In place of 128, we have to take a range. Suppose 150 to 250 or 150 to 225. If any pixel value lies within that range, it is converted to 255. That is white color. In other color are converted to black color. That is, you will get an output image which is either in black color or white color. No other color are present. Okay.
Got it, sir. Got it.
So there are some filtering. It is also a one type of enhancement. After filtering, so as the names are filtering, so it is a process that removes some unwanted component or small details in an image. So filtering means that it filters something, and it is filters mainly unwanted unwanted component. So if a image is contains some unwanted component, that component we don't want in our image, we may apply some filtering process. And in digital processing, filter is basically a sub image and is known by various names such as mask, kernel, template, and window. These are some terms are associated with the filters. There are some masks used for that purposes. We use mask in our face, so that means some part of are visible and some part will not visible, and it is one type of filters. So filter can be also two types. It is also used in spatial filters and also frequency domain filter. First, we have discussed. Let us go discuss the spatial filter. Spatial filtering is one of the main tools used in variety of applications such as noise removal, bridging in gaps in object boundaries, and sharpening the edge. And these are some noise removal. If these are noise are there, some spurious image values or pixel values there. And if there is some gap, that is some pixel values missing, and that is known as bridging. Bridging of the gap, there is no gap, you have to bridging the gap in object boundaries and sharpening the sometimes the edges are some curve are there, you can make sharpening it, and for these purposes partial filtering is used. And the main purpose of the partial filtering to get an enhanced picture, a picture with better quality. What is the idea? The idea of partial filtering is move to a mask. Okay, you know that the meaning of the word mask. Your password is masked, your account number is masked, your Aadhaar card number you may make it masked. And something is masked and something is visible. And it is for basically used in the security purposes. But here also you can use some mask. And the mask is nothing but it is a matrix of square. Square means it is a form of a square, form of a square matrix of odd size. This is important, odd size, either a 3 cross 3 matrix or 5 cross 5 matrix and so on. So it is any odd size, odd order matrix over the whole image pixel by pixel. That is, we have to filter the pixel by pixel. We have to check the pixel by pixel. And if one pixel you get, that is, it is spurious and it is missing, so you have to edit or manipulate that value. Okay, so that is called the filtering. That is, it filter that value. So the name is filtering. At each pixel, the corresponding value of the mask and the image are multiplied and added up to replace the original gray level value of the pixel. This process is known as convolution. You will may get a question. Write a short note of convolution. So this value, that is that pixel value, each pixel value is manipulated. If it is spurious, it is manipulated to get a new pixel value. And there are some techniques to get a new value, that is manipulated values. How it is? Now you see, that is the image are multiplied and added up to replace the original value. That is, all the values of that row is multiplied and then added. And this process is called convolution. We have one good example. But before that, you see, there is a mask. For example, it is not a 5 cross 5, but assume that this is a 5 cross 5 matrix and this is the center. This is center. You see there is a pixel whose value is xy. You see the first image, original image. There is a pixel in the mask which is almost in center of the mask. And suppose we find that pixel value is spurious. That pixel value, there is some gap, or it is spurious, or that should be this value should be corrected or filtered. So after filtering, you see, we get this value. That is, there is a that gray color you change to the black color. That is the pixel which was at the position xy, which has some gray color, you see, now it is converted to the black color after filtering in the right side picture, the same position at xy. So after filtering, you will get a black color. That is the manipulated color, edited color of that pixel. By this process, we create a new image where gray level value of the pixel are calculated from the values under the mask. These values under the mask are modified by a function called filter. Okay, so under the mask, each pixel one by one is manipulated, is calculated, and we get a new value, which the values under the mask are modified by a function, and that function is called the filter. That is, that value is not manipulated by any value manually or by our wish. You cannot manipulate it by your own. There are a function is used for that purposes. It is called filter. If this filter function is a linear function of all gray level value in the mask, the filter is called a linear filter. Yes, it is called non-linear filter. If the function is a linear function, is a linear value, it is called a linear filter. Else it is called a non-linear filter. Let us see what are these filter. You see, these are the spatial filter, which is divided into low pass and high pass. That is known as a smoothing filter and sharpening filter. In linear filter, the average filter is there. Non-linear filter, medium and maximum filter there. Your first derivative filter and second derivative, which was not in your course, but comes under the sharpening filter. So these are the classification of spatial filter. We'll discuss by all the smoothing filters, average filter, median filter, max filter, min max filters. Let us first see what is smoothing. You see, here is smoothing. In spatial filter, you left side, you see the first part is smoothing, which is a low pass filter. This type of filter is used to blur the image, smooth the image. Therefore, it is called smoothing filter. This filter is also used for noise reduction. So noise reduction can be done by blurring with a linear filter, in which operation perform on the image pixel are linear, so or a nonlinear filter. Similarly, sharpening, this filter is used to highlight the transition of intensity. These are based on the first and second derivative. So there are two type of filters in a smoothing and a sharpening. Sharpening basically used for the derivatives, but the smoothing is used in taking some function, some linear function or non-linear functions. So the function of the smoothing filter, which is known as low pass filter, leads to softened edges and noise removal. It is only the edges is softened. If the edges are some, if there is gap, it will be filled, and noise if there is a noise, some unwanted component are there. But high pass filter, which is deals with the first and second derivative, it leads to edge enhancement. So let us see how it works. What is the process? Let us discuss the process of linear filters. Linear filtering Linear filtering is a spatial domain process where a filter mask kernel template is used with some integer coefficient values is applied to input image to generate a filter output image. That is, some mask is used here. And some integer value is applied, some linear function is used, and the mark size generally a 3 cross 3 matrix or a 5 cross 5 matrix or a 7 cross 7 matrix, any odd size, and filter is centered at a coordinate xy, which called the hotspot. You see here, if we will use a mask of 5 cross 5 matrix, you see there's a 5 cross 5 matrix, or 5 plus, you can tell 5 plus 5 mask, and the pixel which lies in the center, exactly center, you see, which is marked as a line. You see some line mask, a pixel which is center, which is at centered, is marked some line and referred as a hotspot. That means this mask, when kept on a image gray level values, and the pixel which is exactly at center, known as a hotspot center, a hotspot, which is as a hotspot. That means we are going to manipulate the value of that pixel at that position. That is, which is at hotspot. The other pixel value is remain unchanged. The other pixel value remain unchanged, and then the marks will be forwarded either moved to either towards right or towards left to get a new hotspot value, to get a new hotspot pixel. So the mask will be moved either in up or down or left or to right to get a new value. Linear filtering of an image fxy of size m cross n and filter max of size m cross n, that is here is suppose the image is m cross n, but the filter size is m cross n. Suppose let it 3 cross 3 or 5 cross 5, and the value is gxy, which is calculated by summation of fxy into wxy, sorry, wij. And the right hand side of equation 1 denotes the set of coordinates covered by filter. For a 3 cos 3 filter, which coordinate wij is output image at coordinate xy is calculated as these are some rules. We carry out the following steps from linear filtering. Step 1, position the max over the current pixel so that hotspot, suppose W00, coincide with the current pixel. So the pixel value which you want to manipulate, it must be under hotspot. From all products of filter elements with the corresponding element in the neighborhood, you form all product, multiply and make addition. We have a better example, good example. So this is step 2. In step 3, add up all the products and store it at a current position in the output image. Divide it by the scaling constant, sum of all coefficient of the mask, and you will get the new value now. This must be repeated for every pixel in that image. So you will get a new image, an enhanced image after filtering of the original image. Let us see. Suppose I have a 3 cos 3 mask and the fxy, the original gray level value is given, and fxy is the order 5, and the mask we have to take a 3 cos 3 marks. And if we kept the mask on the original image, where is the hotspot? The middle. If there's a mask, you see there's a small rectangle within a larger rectangle. I kept a mask of 3 cos 3 there, and the hotspot is on 4. The 4, which is marked by a circle, like an ellipse. You see there's an ellipse. Now, I have to multiply this mask with wij and added. That is, I want to get a new value for the pixel which is on hotspot 4. So you see here, that is we have to add with wij. Wij is 1 by 9, 1 on 1, 1 on 1, 1 by given. So 1 by 9 into 5 into 1 plus 1 by 1 plus 2 by 1, that is every element is multiplied and added, plus 4 by 1 plus 4 by 1 plus 7 by 1 plus 2 by 1 plus 6 by 1 plus 20 by 1. So if we add something, it gives 49. And to get the average, the number of element in the mask is 9. The number of element is mask is 9, so that is why I have multiplied, that is divided 49 by 9, and it is will get some value which is near equal to 5. That is 4 point something, as it is 49. So if you rounded it, you will get near equal to 5. That means the pixel value which was the 4, now it is multiplied to 5. Sorry, now it is converted to 5. So after using the linear filter, the value which was in the 4 is now become 5. So we get this value is 5. Initially it was 4. Similarly, you see in picture B. In picture B, I have just shifted the mask towards right. As it is shifted, the value of hotspot which was in 4, now it is on 7. So in similar process, the value of 7 is manipulated. The value of pixel whose value is 7 is now is manipulated. Same rule, you see. But to see, we have to take all the neighboring element, not the other element which is outside of that mask. That is 1 into 1. You see output is 1 into 1 plus 2 into 1. Where is it 2? 2 is inside a mask. 6 is inside a mask. I have not taken 7. You see there is another 7 which is in the right last column. First row, last column. I have not taken that 7 in my calculation because it is outside of the mask. Okay, I have not taken 8. 8 is outside of the mask. I have not taken 3. 3 is last row, last column. 3 is outside of the mask. So to calculate 7, to calculate the new value for 7, I have only included all the element which is neighboring to 7, which is nearly to 7. Okay, so now what I have done, I have shifted the mask 1 pixel toward right so that the gray label 7 coincide with the hotspot, and I have exactly calculating the output for that pixel position and replace the output image, shift it right again to locate a new value, then shift towards left, toward right, toward up, toward down gradually to replace all the new all the old value by the new value. Got it?
अगर प्रॉब्लम करेंगे तो ज्यादा समझ में आएगा सर, बट या थियोरेटिकली तो समझ में आ रहा है.
No, it is actually not difficult. It is simple. It's not difficult. Only so the hotspot value is calculated and they are multiplied the corresponding value which is W, and then it is divided by the number of elements 9, and now the value is 4 is replaced by 5, and similarly then I shifted the right towards the right to get a new value of 7, then 7 value is manipulated and get a new value. Similarly we shifted if we shifted from again right, you will get 5 as the hotspot, and we change the value at 5, and similarly we shifted the value to up, to down, to left, to right, so that to change all the value of that matrix. You see in the last you see that
Sir,
you see now
Sir, filter is always taken as 1 1 1 1.
No, it is I have taken an example that I have taken W as 1 1 1. It's not necessary that always take 1.
It may be taken as 2 2 2 or 3 3, but
You have taken. That is actually WIJ is given in the question in here. WIJ is given in.
But if we select 1 or 2 or 3, but it will be similar. All the values, 3 by 3, 9 by 9, it will having the same values.
Similar.
Okay, sir. Okay.
So now you see now the 7 value is replaced by 6 near equal to 6, and then I have shifted. Then now go back to the first position of the mask and shift it down. If you go to down, we will get the pixel value. Which one? You see, 6, I think. It's now centered at pixel at a gray value 6. You see, just below the 4. And we repeat the same process, and we will get a new value which is near equal to 8, and continue this doing over all the possible pixel in the image, and you see we will get the new values are there. So by shifting the mask over the whole image, a new image is generated. These value are rounded up to the nearest integer value, because we will get some real number value, so that value must be rounded to the nearest integer and put in the output image as given below at corresponding pixel location. You see, I have calculated some values and I have written that values. 5, 6, 8, 5, 6, 7, 4, 5, 6. So I have only calculated these 9 values. And this is the new values after filtering of fxy.
The star means the
Star means
value.
I have not calculated. I have not calculated here.
No,
Because
sir.
where is the star? Where is the star? I cannot keep my mask there. You have
Yeah,
taken
yeah.
more image.
So
Because
these values remain the same.
remains same. That is, you have to take the other side of the image. If you take other side image, that value can be calculated. But I have taken only m cross n or 5 cross 5 matrix. So in 5 cross 5, I have only able to correct only 9 values. I cannot keep the values. You see the image.
Yeah, yeah.
You see the first value is 5. I cannot keep my mask there. If I keep my mask then 5, some part comes outside of that matrix. Okay, so that is why I have taken the star there.
It means that at the edges the picture cannot be smooth.
Yes, that is, you have to take the other part. I have taken only part of the pixel, part of the image.
Yes.
I have taken only the part of the image. It is FFI, not the whole image. Okay, it is some
Okay.
part of the image.
Okay.
Okay. Hmm.
Excuse me, sir.
Hmm.
So, sir, in the exam, if you are writing like this, it will be correct, no?
Yes,
The edges we are putting star because we
you are
have
putting
one
star.
question in assignment also. So,
Yes, you are putting star there. That is star
star.
indicate star indicate that you have not calculated that value.
Okay, so that
Okay,
is fine when we are
yeah, that is
solving.
fine. That is, you cannot calculate, or in example, you need not to calculate the values of all. You have already taken 8 or 9 pixel and shown that.
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
Okay. So the aim of the image smoothing is to diminish the effect of the camera noise, spurious pixel values, and mixing pixel values. So smoothing only used for these purposes. It is so that is known as a low level pass. It is only used to diminish or decrease the effect of camera noise, spurious pixel values, or mixing pixel values. Some value is a mixing, which is known as a gap. Some spurious pixel, that is some pixel value is not expected. That value is not expected there. You can calculate that value. So this is done by the another pixel or huge averaging filter. Averaging filter. You please recall, averaging filter is the part of the is one the type of smoothing. It comes under the smoothing filter, low pass filter. And as the name suggests, average filter, each pixel is replaced by its another pixel value, another intensity value, which is the average of that mask. Let us see. The last point is there. each pixel is a smoothing image gxy is obtained from the average pixel value in the neighborhood of xy is input image. That is, you have to take that average value. That is, if some pixel is spurious, and you find that and you expect that and you assume that this is if there is maybe a spurious pixel, you have to manipulate it by the uh, average filtering, using average filtering, and by taking the average value of the neighboring image pixel value of the neighboring pixel. Well, same thing is written here. That is, the image gxy is obtained from the average pixel value in the neighborhood of xy in input image. Such a mask is known as mean filter or average filter. It is either known as average filter or mean filter. Please wait 1 minute. The smoothing image. Sir, can you share that question with me? That is, you send me my number. I will see that is what type of questions.
Yes, sir.
I also have some question previous years. So we'll also discuss that question. The aim of image smoothing is to diminish the effect of the camera noise, spurious pixel values, mixing pixel values. So have you got for a project MCS 232, I think? Have
Yes,
you
sir, we have
started the project?
submitted.
Have you started the project work?
Yes, sir.
Submitted.
Submitted. I think the Mr. Datta sir will be the charge of the MCS 232 or not? No,
Yes, sir. Yes, sir.
Ratan Kumar Datta na?
Yes, sir. He will be guiding us.
अच्छा ठीक है. So the aim of the image smoothing is to diminish the effect of camera noise, spurious pixel values, and mixing pixel values. So this is the work of smooth image, only to remove the noises. And this is mainly done by your average filtering. As you know that average filtering or mean filtering is used for that purposes. Each pixel in the image XY is calculated by taking the average pixel value. Such a mask is known as the mean filter or average filter. Smoothing filter is used for the following purposes. It reduces the sharp transition in gray level. It reduces the noise. It blurs edges, and this is the side effect. It blurs edges, so edges may be blurred, which is a negative effect. This is a side effect. It helps in smoothing false occurs. It reduces irrelevant details in an image. And let us see how it is works. Blurring a side effect, which I have discussed in the previous slide. It is a side effect of smoothing filter, is used to pre-processing steps of for following applications. Removal of small details from an image prior to object extraction. Intensity of smaller object blends with the intensity of smaller object blends with the background, and the larger object becomes blob-like and easy to detect, which is a side effect. Bridging small gap in lines or curves of the boundaries of object and text. And small gaps in boundary can lead to enormous result in object extraction. Smoothing fills up all smaller gaps and helps in producing correct results. So these are the use of smoothing. It is linear filter have an important disadvantages. Image structures such as individual point, edges, and lines are blurred. This we know that blurring is a side effect. Overall quality of the image reduces in some application. These side effects are not tolerated, which limits of usage of linear filter. And sometimes the quality of image reduces in some application. In some images, where we use this linear filtering, some its quality decreases. Where is the mean? This is the median mean. Where is given the like that. Then median filter. Uh, that is median filter are the edge preserving smoothing filter, where the label is set to the median of pixel values in neighborhood of that pixel. That is, the pixel value is replaced by the median value in place of mean value. It is not impossible to design a filter that removes only noise and retain all the important image structure intact, because no filter can discriminate which image content. So it is not possible to design a filter that remove only noise. It is also some drawbacks. Median filter replaces every image pixel by median of the pixel in the corresponding filter region S of xy. Like unlike your mean filter, which is replaced by taking the average or mean of the neighborhood pixels. Here the median filter is takes. Median filters, that is the median of the text. Median means the middle value. The middle value, please call the mean mode median. Median is the middle value of all neighborhood pixel. It has excellent noise reduction capability. It has the advantages. It preserves the edges. Sometimes the edges in mean filter were disturbed, but here it preserves the edges. It introduces less blurring than smoothing linear filter. So we know that blurring is a negative impact or a drawback of smoothing linear filter, but it is here introduce less blurring as compared to that. It is very effective in presence of impulse noise. We know that the types of type of noise. We will discuss about the type of noise. The type of impulse noise. It performs poorly if the number of noise pixel in S. If the number of pixel in S is greater than the half of the number of pixel in the window X, it is 1 point. There are two dots are there, but it is 1 point. If the number of noise pixel is greater than the half of the pixel, that is, if you get more error, if you get more image, more than half of image contains error, it performs poorly. It performs poorly in the presence of Gaussian noise. There are some types of error. We'll discuss about that. Impulse noise, Gaussian noise, they are there in our later slides. And in Gaussian noise, it is performs poorly, but it is very effective in presence of impulse noise. Let us see an example. To apply the median filter, we have to first sort the pixel according either in the ascending or increasing order or decreasing order. So once it is sorted, it is easy for us to get the median value. Then assign the median value to that pixel which was in the hotspot. You see here. Suppose this is a fxy. I have taken a 3 cross 3 matrix. and mask is also 3 cos 3. And the value which is at center 0, there are 2 zeros, but the center 0, you see, the value which is at the center is a what value? Hotspot value. That is, I am going to change that value. That suppose that is the error pixel, and I want to get its new value. And to achieve this, we have to take all the element of the mask 372100958. You see, I have taken all the neighbor elements. Now I am going to find its mean. Sorry, median. It is a median filtering. If it was a mean filtering, you have to take the mean. You add all the elements divided by 9. So to get the median, we have to sort it first. If I have not sorted, it is difficult to find the median. First,
सर सॉरी टू इंटरप्ट यू, ये लास्ट में जो अरेंजमेंट है सॉर्ट किया गया है किस ऑर्डर में वो है 0012?
ascending order में, increasing
ओके
order
सो
में नहीं?
ओके सो जो बॉक्सेस में लेफ्ट हैंड साइड में एफ एक्स वाई में है वो सारे के सारे एलिमेंट उसमें ले रहे हैं हम लोग ना?
हाँ.
ओके
You take the median of all the elements, all the neighboring elements which are present inside the mask.
सर अगर वैल्यू अगर मान लो कि 10 होता, इफ द नंबर ऑफ द द एलिमेंट इज 10, देन हाउ कुड वी फाइंड आउट द मीडियन? डिवाइड करके लेना पड़ेगा बिकॉज इसमें तो 9 है
Mask.
तो
No. Mask must be a 3 cross 3 matrix or 5 cross 5 matrix, any odd size. It cannot be 10.
ओके सर
Okay, so mask be any size can order 3 or order 5 or order 7, like that. So as it is a 3 cross 3 mask, you have maximum 9 elements. Okay, you have to nine elements. So that 9 elements are taken, then it is sorted. Okay, then these number are sorted, and after sorted, you find the median, which is the mid value is 3. Maximum is 9.
सो लास्ट में
One,
जो
two.
लास्ट में जो डायग्राम है उसमें जो 3 है दैट इज द मीडियम 1, बाकी सबको मास्क हम लोग कर दिए हैं, ऐसा है?
नहीं, max नहीं है. In my example, I am going to change the value of 0, which on the hotspot. So 0 is replaced by 3. Other value I have to change one by one. Then I am shifted the mask to right to change the second 0 value. Then I have to shift the mask to up to change the value of 7. Then I have shifted the mask to the down to get the that is 5 will be the hotspot.
सर लास्ट वाले डायग्राम में जो मास्क हो रहा है स्टार इज रिप्रेजेंटिंग द मास्क ना?
No, star does not mask. I have value of star. I have not calculated it. I have only
Last
calculated
वाला
the value of 0. The last one,
लास्ट वाला जो
GXY,
बॉक्स जो है
last
हाँ
वाला जो GXY लिखा हुआ है, GX
हाँ,
लिखा हुआ है, only here in an example, I am going to change the value of 0. That is a 0 is replaced by 3. The new value of 0 will be 3. And other value so far I have not calculated. That is I
सेंटर वैल्यू
star.
सेंटर वैल्यू वी हैव रिप्लेस्ड विद द मीडियन दैट इज 3, राइट?
Yes.
ओके
Okay. The other value I have not calculated so far, and you have to calculate it one by one. So this is a median filter. So if it was a mean filter, I don't have any size. Suppose mean filter in my slides. I have not taken the example. I think if it was a mean filter, you have to take the mean here. In place of median, you have to take mean here. That is, you add all the number 1 plus 2 plus 0 plus 3 plus 5 plus 7 plus 8 plus 9, and divided by how many number are there? Divide that. So that is the mean value. So the replaced value is mean. You see, here is a compute the median value of the pixels shown below using the 3x3 max. Compute the median value of marked pixel shown below using a 3x3 mask. You see here, if I put a 3x3 max, first 3x3 value, first 9 values, 3 row values, 3 column values, each comes under the mask. And 128, I think, is the hotspot value. Okay. So 128 value can be multiplied, can be calculated. Okay. It seems the value of 128 is spurious because you see the neighboring value, you see it is 18, 22, 33, 24 is less than 30. But 128 value is greater than its neighboring. So it may be considered as a spurious image. Spurious image whose value is need to be examined.
It may be
Or
due to some noise.
recalculated.
It may be due to some noise.
Yes. Due to some noise, due to some suppose camera movement. When you capture a camera image, suppose you
Some
move your
sort
hands or move camera.
some sort of sensor fault also.
Yes.
Yes.
So you see here, I have taken the median of these 9 elements: 8, 22, 33, 34, 128, 24, 2, 22, 19, 32. Then I am sorted it. The median of 18, 19, 22, 22, 24, 32, 33, 34, 128. Okay. As it is 9 value, so the median value is 9 plus 1, 10, 10 by 2, 5, fifth value. The fifth value will be the median. Total number is 9. As 9 is an odd number, so 9 plus 1, 10, 10 by 2, fifth. The fifth value will be the median. 18 is the first, 19 second, 22 third, 22 fourth, 24 is the fifth. Okay. So 24 will be replaced by 128. Sorry, 128 will be replaced by 24. Okay. Similarly, you see, if we shifted the mask towards right,
सर could you tell me ये थर्ड वाले पॉइंट में मीडियन का जो वैल्यू लिया है हाउ 34 हैज टेकन 33 से फिर से स्टार्ट हो रहा है 33 25 मतलब फर्स्ट रो में मैं देख रहा हूँ आई एम सीइंग इन द फर्स्ट रो 33 25 एंड 32 फर्स्ट रो 3 एलिमेंट नाउ सेकेंड रो 3 एलिमेंट ऐसे होगा ना 34 नहीं 34 यहाँ कैसे आ रहा है वो समझ नहीं आया यहाँ 172 आना चाहिए था ना 172 26 33 ऐसा होना चाहिए था ना
No, I am doing
34
33,
कैसे आ रहा
25,
है
1 minute, 33, 25, 32, then 24, 172, 26, 32, 31, that is
हाँ
24 is missing. 24 is missing.
34 हाँ वही आई एम टेलिंग यू
हाँ,
कि
24
ये
is
जो है
missing.
ना
That is 1,
एक
2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 20. In place of the 24 is taken that.
34
Before 172,
हाँ
in place of 34, there should be 24,
हाँ
not 34.
24 होना चाहिए 34 नहीं होना चाहिए ना वो
24 होना चाहिए. Yes. It is mistakenly
एरर
34.
है इसमें
That is, if I shifted, then again towards right, 172 is the hotspot. 172 the hotspot. So if 172 is hotspot, then 33, 25, 32, 24, 172, 24. 24, 172, 26, 32, 31, 28. Yes, yes. There, before 172, that must that in place of 34 there should be 24. 24. 34 mistake is written there because in the mass 34 is not there. So in this way, I have calculated the other values also. And finally, I have calculated some values. In this way, you can calculate the value of all other pixels. One is 26, you see, another is 31. So this is the mean filter, and this is the median filter.
Is there any mode filter also?
No, mode filter is not there.
Okay.
Mode filter is not there. The max mean filter is there. The minimum filter is there. Maximum filter is there. That is, you have to replace the maximum value of that max. In first case, we have to replace the mean value. Second case, the median value. And if it is replaced as the maximum value, it is the max filter. And if the all values replace this hotspot value is replaced by your mean value, that is called the mean filter. It has also other. It is used in other purposes. Where that is, you have to apply the filters according to your requirement. Mean filter is used for one purpose. We will discuss. Max filter is other purposes. Median filter is also. Mean filter is also. So you have different application to apply these filters. Okay. So maximum and mean filter we will discuss in the next class. Please, I will
Sir,
take the.
one question I want to understand. Sir,
Hmm,
what
hmm,
could
hmm.
be the real application of this, the study of these pictures in the real scenario? I
Filter.
mean, in the
Filter.
real world. नहीं, ये जो हम लोग सब्जेक्ट पढ़ रहे हैं, what is the real application of this, the points
You
in the
see,
current scenario? कहाँ
basically it
use
is
होता है applications इसका?
application में होता है. Suppose you are you have to process an image, and you have to interested in a part of the image. You have to view that, and you want to improve the quality of an image. Okay. So suppose I have you see, suppose I have sent a message to image to you, and you found that image is not clear. You have to suppose post that image in your magazine. Okay, suppose I have sent you an image, and that image you want to post in your magazine, that is you have to publish it. And you found that image is not clear. It does not give any information. You cannot gather some information from it. What to do? We have to
Okay, so
enhance the quality. Okay, suppose one photograph.
So media industry में this
मीडिया इंडस्ट्री में फोटोग्राफ में जो ये
फोटोग्राफिंग में
फोटोग्राफ में फोटोग्राफ नॉट क्लियर, 2 मिनट में उसको बना देते हैं, नहीं नॉइज रिमूवल कर देते हैं. Obviously tools are available there, but how these tools are actually designed, so these are applied in that software.
So sir, is there any tool where we can use this kind of concept?
There are various tools available in the market. Okay, Photoshop tools. There are various tools. You will get also some online. You will also get some online tools.
रियल
Okay, you put
एप्लीकेशन
that clear
इंडस्ट्री में
image.
इसका कहाँ है, हाउ कैन वी डू दैट? नहीं, इसके बारे में एक बार प्लीज आप बाद में बता दीजिएगा, नोट इन दिस क्लास ओनली,
वही तो बोल रहा हूँ,
सो
real
दैट
application. Make I send a photo to you. That photograph is not clear. That is the real application. You can clear the noise, clear the image, the noise, clear the blurring, clear the brightness, and you get a enhanced picture. That is the real
फोटोशॉप के थ्रू वी
application.
कैन डू दैट, फोटोशॉप के
Photograph.
थ्रू वी कैन डू दैट।
Suppose you have to, suppose you have to take a printout of the photograph, but you found that the photograph is not clear at all. You will not get any information from that. Okay, so make you can increase it quality. So that is your digital image processing.
पर
Image को processing करना.
इसका यूज कंप्यूटर विजन और रोबोटिक्स में भी तो होगा ना, जहाँ पे
हाँ होगा,
जैसे
हाँ कंप्यूटर विजन में.
सेल्फ ड्रिवन कार्स वगैरह में तो भी होगा ना।
फर्स्ट ऑफ ऑल मेडिकल में, डायग्नोसिस में, सैटेलाइट इमेजरी में है सबसे ज्यादा, तो वहां भी यूज होगा, और कंप्यूटर विजन में तो है। और डे टू डे लैब में बहुत से ऐसे ऐप आते हैं जो, जैसे पिक्सल लैब हो गया, और बहुत से ऐप हैं जो हमारे उसको इमेजेस को सही करते हैं, और उसमें भी काम होता है।
रिमोट सेंसिंग में भी ज्यादा होगा इसका यूज ना?
यस यस, डिफेंस टेक्नोलॉजी में बहुत यूज है इसका।
वही जासूसी बोलने वाला था मैं, जासूसी में काफी यूज होगा।
Those who have not written their name and number, registration number, please write. Do not repeat. Those who have not written, only write.
तो अभी अगली क्लास तो 3 बजे है ना सर?
हाँ. Okay, so let us
Sir,
leave.
sir, right now can we leave?
Yes, you can leave now.
Okay, sir. Thank you, sir.
थैंक यू
Thank
सर।
you all. Thank you.
Sir, that PPT is enough for MCS 2030.
I think enough. You can also that is, you compare the question, you will get most of the question from this slide.
Okay,
I
then
am not
the
telling 100%. You will get most of the question.
entire all blogs are included in that PPT, no? So we
Yes,
can.
yes.
Yes. Thank you, sir.
थैंक यू सर।